Hey, I'm Craig. It's great to have a chance to talk to you all. And thanks so much for taking the time to come out here and spend the day with us. I'm the founder and CEO of Stacklok. And I wanted to just talk about the tool pollution problem. I think it's come up quite a bit during the day. You know, we've talked a lot about the utility of MCP. It's as a bridge to adjacent systems, like opening the world of traditional systems to these AI-based workflows. And when you think about the work that you're doing with AI, you have this amazing new system that's able to generate semantically relevant responses to inputs from this sort of incredible process of generating these sort of vector embeddings. And when you think about what you're actually doing on a day-to-day basis, what you're really trying to accomplish is context real estate management. Like it sounds pretty mundane, but when you think about the sort of anatomy of a context window, when you're working with these tools, there's a lot of stuff that has to go into there, right? So obviously, system prompt represents, one key facet of what defines an agentic experience. You also obviously have the user interactions and the session interactions that provide the context of where something is in its workflow. You have a lot of workload or workflow specific context that has to show up there. So if you're dealing with cursor, that's like a code base and resources and a variety of other things. And then obviously you have tools as well. And when you start to think about the dynamics of this, it's not just about jamming all of that context into the context window so you can do work. It's about presenting the most semantically relevant context for the task that is currently being done at hand. And one of the key things that's driving context pollution is tool calling. And I think there's three essential challenges that come out of this. The first challenge is obviously cost. Input tokens are not free. You certainly will probably at some point in your journey have a moment where you get that AWS bill and you're like, or that OpenAI bill, or that Anthropic bill, and it's like, wow, that could have been a 2016 Honda Civic that just went out the door as a result of unfettered token utilization. And so as we think about these use cases, like the cost consumption is real. What's perhaps worse though is noise. When you're starting to deal with a lot of tools, as I said, it's really about getting the most semantically relevant context into the environment at the time. And when you start to push a lot of tool descriptions into a system, those aren't semantically relevant to the problem at hand in the general case. And as a result of that, you start to see degradation of performance. Now, modern large language models are fantastic in terms of their ability to deal with the self-attention mechanisms, the ability to deal with increasingly large context. But you're going to find situations where you want more efficient inferencing, where you want lower latency performance. And having all that noise being jammed into the context window just doesn't help you. And then the third area where I see a lot of challenges is this concept of dynamicism, right? Like the world is changing pretty quickly. You might be working on something. A lot of the solutions that people present for the problem of context pollution is like, well, just be disciplined about which tools you're turning on and off, and make sure that you're only presenting the right tools at the right time. There's really two problems with that. Like, for humans, we're lazy. We're not going to be wanting to go and press buttons to turn on and off tools. But also for a lot of these class of systems, you don't know at offset which tools are going to be necessary to complete the task. So we have to find some alternative solution to deal with this. And I thought to kind of make it real, we've heard a lot of these sort of discussions. Like, I grabbed this as a blog contest. This is one of the older sort of versions that I found where the person was like, holy crap, MCP is great, but like, look at what it's doing to my context window. And this is pretty typical, right? Like a lot of tools are generating a lot of spurious context, and we need to find a solution to navigate that and address that as a community. And so, one of the patterns that I think is going to show up, and we just heard that this is a part of AWS's implementation. We see semantic search as being something that's entirely relevant. Yes, we absolutely hope that over time we'll get to the point where the MCP protocol supports this natively. But in the meantime, if you're a developer operating in single player mode using something like Cloud Code, you probably want to have something that sits between you and that system that is helping you reduce your tool clutter. If you're an organization like an enterprise that is building these tools for sustainable usage, you probably need something that sits between your clients and this raft of tools that might be necessary to complete the task. And so an obvious answer here is, hey, why don't we just add semantic search? This is something that you probably should have as part of your MCP portfolio. And turns out it's really easy to build semantic search these days. So let's just build a system that enables us to take an MCP tool description, chunk it, vectorize it, put a semantic engine in front of it, and then instead of presenting 1,000 tools, let's just produce 2 tools. Find tool, invoke tool. And that process of just adding semantic search really reduces token clutter, and it makes these systems incredibly useful. And so rather than talk about it more, I thought I would invite Dan up to just show you what it looks like.
All right, thanks, Eric. Everyone hear me? Okay, yep, sounds good. So yeah, like Craig was saying, right, I'm using ToolHive here. Again, that single player mode, right, just on my machine with some of the tools I use most frequently. That's just 3 MCP servers, so that shouldn't be a big deal, right? Except Cursor's not exactly happy about it. Turns out there's 111 tools across just those 3 MCP servers. And Claude is already warning me, it's like, hey, some models might not even be able to use more than 80 tools, and you're gonna have performance issues. And if I just wanna say, and I don't know why it keeps going red on my Grafana MCP there, but let's say I wanna ask about a GitHub issue. I'd need 1 tool, maybe 2 out of the GitHub MCP, but the model is also going to receive all these unrelated Grafana and Notion tools, plus another 44 GitHub tools that it does not need for that query. And so, like Craig mentioned, we've built something around this. So I'm going to turn on our MCP optimizer feature here. And again, I have these MCP servers. They're running in my default group here in ToolHive. I have a few other groups with some other tools for some other use cases I use. All I need to do is select the group that I wish to optimize. So it contains the MCP servers that I wish to optimize. In my default group, I already have my clients connected. So Cursor is one of them. So ToolHive is managing my client configurations. I'm going to turn on the optimizer for the default group. Now, what's happening is we're actually spinning up an MCP optimizer MCP server. And it is connecting back into the ToolHive API, discovering the MCP servers that are running in that group, and their tools and their descriptions, and indexing them into that vector database. And if I have vamped long enough, it has done that by this point. And I would just need to kick Cursor here once. But it is building that tool, and it's going to present just those 2 tools. It's actually 3 tools. You can actually, there we go. Find tool, call tool, and we also have a list tools tool, so you can actually ask the agent, what tools do I have available? And that's all we need to present to Cursor now. No more warning, just a few tools worth. The way this actually presents, I'm going to go into our playground here within ToolHive. And I'm just going to wire up that one MCP optimizer server. And we can dig into how this actually works. So I was going to use a GitHub prompt here, but since we had a great presentation from Grafana today, I'm going to use my Grafana MCP server. So oops. So I'm going to ask, and here are any of my Grafana alerts firing right now? And what we're going to see happen through the optimizer MCP, if Claude wants to get back to me here. There we go. First thing we're going to do is call find tool with some input keywords. And this is going to execute that semantic search through the optimizer's database and find the right tools to use. And we can see the result of that is one of the tools we returned is the list alert rules tool from the Grafana MCP. And then the next step is to call the tool. And so the agent is going to ask the MCP optimizer to call the Grafana MCP list alert rules tool, and we get our result like normal. And it looks like, hey, great, no firing alerts. That's awesome. And by the way, the Grafana dashboard I'm using is one that I've been using to monitor the telemetry from my ToolHive MCP servers because I'm outputting Prometheus metrics from them. So everything's happy and healthy. The other thing we can do is we built in some internal metrics here. So what did that actually save us? You can actually ask the optimizer, what did I just save in terms of token usage? And we'll see here that the baseline of all the tools that I would have sent as tool names and descriptions would have been 38,500 tokens. What we actually sent was 1,300 tokens. So in this case, it's almost, it's 96.5% savings in the token usage. And Craig's going to go into a bunch of numbers around like what that actually means at scale.
Dan, before you go, how do I switch back to my presentation here? There we go. All right.
You got it.
Yeah, so I mean, the advantages here, obviously, dramatically reduced input token consumption, as you see. It's a nice benefit of this class of system. There's improvements in both the performance and latency associated with these activities. There are tangible benefits to reducing context clutter when you're looking to perform agentic tasks. And the other nice thing about this is this class of system handles the tool dynamicism for you. So new server shows up, gets registered, just gets indexed. You don't have to change the client's configuration. You don't have to futz with anything. You can just start to consume it. So in terms of like what we see out there, and these are real examples from the use of Cloud Code. Layer in these 3 servers, say hello. Your cost for 3 million input tokens is, for a million input tokens, about $3. Without Semantic Search Tool, you're paying 14 cents. With Semantic Search Tool, you're paying about 3 cents. Now, when you think about that, like times that by 200 queries per day per developer, times that by 100 developers, times that by 300 work days, you're probably saving an organization like that at least $600,000 a year just on the input tokens. Now, look. Let me also be clear, input token caching helps. This is one of these sort of moments where I put sort of asterisks up, but it doesn't always help in every situation. So there are some capabilities that exist that will sort of partially mitigate this, but I think it's beneficial, especially since this is free to use. You can just deploy it on your desktop right now. The single player mode works just great. Give it a go. The thing that I find more interesting, though, is the quality of service capabilities. So we ran, side by side. So like this new world, the proof of life is not just something working. You actually have to run evals. So we ran pretty exhaustive evals, building synthetic data, and looking at models' abilities to effectively just identify the tool that should be called for a specific task. Now, I didn't draw error bars on this. I probably should have. With Cloud Sonnet 4, Cloud's actually pretty good at tool selection. And with or without the semantic search, it was effectively within the same basic error bar for a collection of something like 60 tools. When we went down to the Gemini 2.5 Flash, we saw significant degradation in tool calling performance when you had an overwhelmed or overloaded context window. When you start getting to the much smaller models, like the GPT-OS 20 billion model, forget about it, right? They really are not great at tool selection. And that's really just an indication of how much that context clutter is hurting you, especially when you start to move down the models and looking for more performance or more cost-effective options for your work. So with that, I just want to say thank you. All of this is a community project, and it wouldn't be practical without folks working with us in the community to make this happen. If you're interested in what we're up to, check out toolhive.dev. It's an Apache 2 licensed open community project. Right now, it's mostly us and Red Hat that have been working on the project. We would love to make that more people. So we're looking for folks that are, hey, you want to cut your teeth on open source? You're interested in this space? Come party with us on ToolHive and see if you can kind of make that a part of your day-to-day work. Join the discussion on Discord. We have a pretty active Discord environment. And then if you want to talk more, hit me up on LinkedIn. I'm local, and really appreciate the time today.